Okay, let's finish what we started last week. So quadratic equation using quadratic formula. Using the quadratic formula. So we formulated the quadratic formula using the completing squares. And I don't think I need to repeat it again. So we got a formula of this form: x equals to minus b plus or minus the square root of b squared minus 4ac all over 2a. Then we said we have a discriminant. And the discriminant is this, the b squared minus 4ac. So that is a discriminant. So this is used to determine the kind of quadratic equation we have. So if the discriminant, we said if the discriminant is equals to 0, then we only have one solution. When the discriminant is equals to 0, we have one solution. When the discriminant b squared minus 4ac is less than 0, we have two solutions. But they are what? Complex. They are complex. So if this one is less than 0, then we, of course, it is the negative. So the square root of a negative is a complex number. And then, so number 1, number 2, and then lastly, number 3, if b squared minus 4ac is greater than 0, we have two solutions. And both of them are, they are real numbers. So they are real. So that's what we did last week on Wednesday. Okay, now let's do the examples. Let's do the example. So example number 1 is, use the discriminant to determine the number of solutions to the quadratic equation. So the discriminant is b squared minus 4ac. So use this discriminant to determine the number of solutions to the quadratic equation. And the equation is minus 4a squared minus a plus 4 equals to 0. So we said our quadratic equation is of this form: ax squared plus bx plus c equals to 0. So a is this value over here, which is the coefficient of x squared. B is the coefficient of x, and then c is a constant. So in our case here, our a is what? Our a equals to minus 4. Our b equals to minus 1. And our c equals to what? Equals to 4. So now you substitute these values to the discriminant here to see whether it is greater than 0, equals to 0, or less than 0. So b is minus 1. So minus 1 square minus 4a is minus 4, and then c is 4. So what do you get here? So you get 1 minus what? Minus 16 times 4. So it is 1 plus what? 64, right? 1 plus 64, which is equals to 65. So 65 is what? Is greater than 0, right? So this is greater than 0. So that means this solution, this quadratic equation has two solutions, and they are what? And they are real. So it has two solutions, and they are real. Another example, use the discriminant to determine the number of solutions to quadratic equation 8d squared minus 9d plus 9 equals to 0. So our discriminant is of this form, b squared minus 4ac, b squared minus 4ac. Now here, our a is equals to 8, our b equals to minus 9, and our c equals to 9. Now we factor this, we substitute this one in our discriminant. So b squared, so minus 9 squared minus 4 times a is 8 times c is 9. So what do you get? So minus 9 squared is what? 81 minus. So looking at this, so this is what? 72 times what? 4. What do you get? 72 times 4 is what? 72 times 4, 8, 288. So 288. Okay, so when you look at this, of course, we will get a what? Minus, right? So that means this one is less than 0. So if the discriminant here is less than 0, then there are two solutions, but they are what? They are complex. So we have two solutions, but complex. They are complex. All right. Another example. B squared 81a squared minus 81a squared plus 90a minus 25 equals to 0. Use the discriminant to determine the number of solutions to the quadratic equation. So our a equals to minus 81, our b equals to 90, and our c equals to minus 20. So b squared minus 4ac. So you substitute here. So b is 90 squared minus 4 times minus 81 times minus 20. So 90 squared is what? 81, 100, right? So this and this is 100. That means this one is 8100. So there is this negative and that one is positive, and then we have the minus. And this one is equals to what? 0. So if the discriminant is equals to 0, we only have one. We have one solution. We have one solution. Okay, now how can we use a quadratic formula to solve a quadratic equation? So our quadratic formula is of this form. So we know that our quadratic formula is of the form minus b plus or minus the square root of b square minus 4ac all over what? 2a. Now, solve the equation 2m squared minus 2m minus 10 equals 0 using the quadratic formula. Now solve that equation using the quadratic formula. So I said last time that quadratic formula can be used to solve any quadratic equation. So you can use this one to solve any quadratic equation. In fact, I think it's the simplest to use because you just substitute the values of A, B, and C there, and you will get the answer easily. So our A here is equals to 2, our B equals to minus 2, and our C equals to minus 10. So we substitute these values to the formula here. So our X will now be equals to minus B, and this B is it. So it will be minus 2 plus or minus the square root of B is minus 2 squared, and then minus 4 times A. A is what? 2 times C is minus 10. Times minus 10. All of this divided by what? 2 times A times 2. So if you look at the discriminant here, the discriminant in our case is, of course, I can see this plus and this plus will cancel. So it will be greater than 0. So definitely we have the two solutions, and the two solutions are what? They are real. So now we can solve it. So X equals to, so this is 4, sorry, this is 2. So the plus and the minus will be plus or minus the square root of minus 2 squared is 4 minus 4 times 2 is 8 times this one is 80. So, and then that one is plus, and that one give us what? 8 all over what? All over 4. All over 4. So what do you get? So X equals to 2 plus or minus the square root of 84 all over 4. All over 4. So you can simplify. So when you divide, when you factor the 81, is 4 by what? 4 by 21, right? So 81 is 4 by 21. So X equals to 2 plus or minus the square root of 4 times 21 all over 4. So x equals to 2 plus or minus. So you remember the product of the roots. So you can get the square root of 2 and the square root of 4 and the square root of 21. So the square root of 4 is 2. And then the square root of 21. All over what? All over 4. Then finally, when you divide by 2, so x equals to 1 plus or minus the square root of 21 all over what? All over 2. Okay. So our answer, so in your Moodle, if you have such a question, then you separate with the what? In a Newton, sorry. You separate with a comma. So our x equals 1 plus the root of 21 all over 2, comma, 1 minus the root of 21 all over 2. That is our answer. So you can simplify using your calculator by getting the square root of this, and then you can round it off to the nearest tens. All right, so we can do one example, and then we'll go to section 9.5. So another example is 4c squared plus 5c plus 4 equals to 0. Solve that one using quadratic formula. So we know our a equals to 4, our b equals to 5, and then our c equals to 4. So our formula is of the form x equals to minus b plus or minus the square root of b squared minus 4ac all over 1 to over 2a. Now our b is 5, so x equals to minus 5 plus or minus the square root of 5 squared minus 4 times 4 times 4 all over 1, 2 times 1 times 4. Then you simplify. So x equals to minus 5 plus or minus the square root of 25 minus what? It's 64. Divide by 8. Now, looking at the discriminant here, it will be negative, right? So it will give you the complex roots. So now let's simplify. So 25 minus 64 is 39. So x equals to minus 5 plus or minus the square root of minus what? 39, right? Divided by 8. So our x equals to minus 5, the square plus or minus the square root of minus 1 is I, and then the square root of 39 there, all over what? All over 8. So our answer is now 5 plus I root of 39 over 8, or minus 5 minus I the root of 39 all over 8. Okay? Any questions? right, so you can still go and check the solutions that I put there, the last example there, and then you also have another example. So you can go check that. If you have any issue, then you can always ask. All right, let's come to the application. How can we apply the formulas? How can we apply the quadratic formula? How to solve it? How can we form the quadratic equation and then we use the quadratic formulas to solve it? All right, so you can be given some of the problems to solve, the word problem to solve. And we had some strategies on how to solve a word problem. So one of the strategies is, first of all, you do what? You read the problem, right? So what you do, you read, and then you identify the kind of problem you're looking for. Like, what are you trying to do? So you identify the problem, identify. Then number two, you can name. So you can use any name there to name the problem. Then number three, then you can translate. You can translate. And then number five, you can solve. And then number six, then you can check if what you're doing is correct. So the very important thing here is number one and number two. So you read, make sure you read, and then you identify what you're looking for. Okay? So example number one there. So 9.58. Did you get the notes? So 9.58. So someone can read for us.
Roy kayaked up the river and then back in 4 times 6 hours. The trip is 4 miles each way and the current was visible. Roy kayaked at the speed of 5 miles per hour. What was the speed of the current? Round your was the nearest.
All right, so what you do is you read. So you read the problem, and then what are we looking for? We are looking for what? The speed of the what? The speed of current. So we are looking for the speed of current. So you name that. So you start by, you can let. There I have let R to be the speed of the current. So let R to be speed of what? Current. Speed of current. So we know that speed equals to distance all over time, right? Speed equals to distance all over time. And time equals to distance all over speed. Distance all over speed. Now, in our case, say Roy kayak up the river and then back the total time of 6 hours. So going and then coming back. And the total time there is what? 6 hours. The total time there is 6 hours. Then the trip was 4 miles each. So the distance the distance going is 4 miles. Distance coming back is 4 miles. 4 miles, 4 miles. Then now, the trip was 4 miles each way, and the current was difficult. So there is two ways there. So either he's going with the current or he's going against the what? The current. So when he's going with the current, then the speed will be plus the what? The speed of the current. Then when he's coming with against the current, then of course it will reduce the what? The speed. So it will reduce the speed. So our time there for the two trips is 6 hours. So we can say the total time. So we can use this formula here. The time is distance all over speed. So we know the distance is 4 miles if he's going. And if he's going against the current, yeah, then it will be, because he's going 5 miles, so it will be 5 miles minus the what? Minus the 1 for what? Current. Then plus, so this is what we're getting the time going. And then the time coming back is 4 miles all over. If it's coming with a current, then plus what? R equals to the total time there is what? 6 hours. The total time is 6 hours. Now we want to solve the value of R. So how will you solve the value of R? So we can multiply by the what? The LCM. And our LCM is 5 minus R, 5 plus what? Plus R. So what you do in this side, you do it in the other side. 5 minus R, 5 minus R plus R. Now solve this. So when you cancel this and that, so you get 4 times 5 plus R plus, cancel that and that, 4, 5 minus R equals to 6. So 5 minus R, 5 plus R is a difference of 2 squares, right? So it would be 5 squared is 25 minus what? Minus R squared. Then now we solve. So here is 20 plus 4R plus 20 minus 4R equals to 6 times 25 is 150. Then minus 6R squared. Minus 6R squared. So this R and that one will cancel, right? Because 4R minus 4R is that. So this is 40 equals to 150 minus what? 6R squared. Minus 6R squared. Now, we can take 6R to the other side. So 6R equals to, take the 40 to the other side, equals 110. So you divide by 6, divide by 6. So what will be our R? So this is R squared. So what will be our R? So R squared equals to 110 all over what? Over 6. So R is now equals to plus or minus the square root of 110 all over what? all over 6. So you get the square root there. So because we are taking the positive one, so we take the what? The positive one there. So you get the positive value there. So R is the one which you get, which will be the square root of 110 all over 6. And that one is, you get the units which are meters per, this miles per hour, miles per hour. So that's how you can solve that. That section. Okay, so we can do question number 2 in section 9.5b. So it says the product of two consecutive even integers is 624. The product of two consecutive even integers is 624. Find the integers. So what are we looking for? The what? The integers. So we can say the first integer is maybe x. And it is what? The even integer. So what will be the next even? So let's say the first even is 2. What will we get when, what is the next even integer? 4, right? So what do? You add what? 2. So the first one is x. So the next one is what? X plus what? Plus 2. X plus 2. So the product of two consecutive even integers is 624. So the product of the two of them is x plus 2 equals to 624. 624. So when you open the bracket, so it will be x squared plus 2x equals to 624. Equals to 624. So we can bring 624 to this side. So x squared plus 2x minus 624 equals to what? Equals to 0. Now we can use the simplest formula. The simplest method to use here is the quadratic formula. So our quadratic formula is x equals to minus b plus or minus the square root of 4 of b squared minus 4ac all over what? All over 2a. And our a equals to 1, our b equals to 2, and our c equals to minus 624. Minus 624. Then we now substitute. So x equals to our b is now minus 2 plus or minus the square root of b is now 2 square, which is 4 minus 4a is 1, then it's 1, and then our c is minus 624. all these divided by what? 2 times A, which is times 1. So minus 2 plus or minus the square root of 4. So this minus and that minus will be plus. 624 by 4, what do you get? 624 by 4. So what you get finally is, so 624 by 4 is 6, 1, 9, and then 24. So 2496. So 2496 is all over 1, all over 2. So that is x. So x equals to minus 2 plus or minus the square root of what? 2500 all over 2. Because when you add 2496, you get 2500. So what is the square root of 2500? 50, right? So x equals to minus 2 plus or minus 50 all over 1 all over 2. So what will be our x? So when you divide everywhere by 2, so our x equals to minus 1 plus or minus 25. So our x equals to minus 1 plus 25 or minus 1 minus 25. So our x equals to 24 or minus 26. So I think we did something like this at the beginning of the semester. So we are looking for two numbers, two consecutive numbers. So these are not two consecutive numbers, right? So this is one of them, and this one is another. So if the first one is x is 24, our next one, there will be 21. Our next positive there, our next even number there will be 26, right? Then we have minus 26. So minus 26. So we say x, and then that's the first one, and then x plus 2 is the second one. So if we have the first one is minus 26, so our next one is minus 26 plus 1, plus 2. So that's our next consecutive number. So minus 26 plus 2 is minus 21. Minus 20, minus 24. So these are our consecutive numbers. These are our consecutive numbers. Okay, let's do one example in section 9.5b. And then you can go study the rest. We can do question number 1. Question number 1. It says the base of a triangle. So the base of a triangle. So if we have a triangle like that. So the base of a triangle is 6, more than twice the height. The base of the triangle is 6, more than twice the height. So our base will be what? 6 plus what? 2h. And our height is h. The area of a triangle is, so our area here equals to 88. Find the height and the base of the triangle. So you read the next one, you identify what you're looking for, and then you name it. So our area of a triangle is what? Half base times what? That is the height. So our base is 6 plus 2h. So area now, which is 88, equals 1 over 2. Our base is 6 plus 2h. And then our height is h. So when you multiply by 2 everywhere, so 88 times 2 is what? 176. So 176 equals to, now you open these brackets, so 6h plus 2h squared. 2h squared. So 2h squared plus 6h minus what? 176 equals to 0. So now you can use the quadratic formula there. So you can use the quadratic formula there. So to make it simple, you can divide everywhere by 2. So when you divide everywhere by 2, then you get h squared plus 3h minus 8 equals to 0. Equals to 0. Now you use the quadratic formula to solve. So A in our case is 1, B equals to 3, and then C equals to minus 8. Minus 88. So, and then you substitute the values there. So after you substitute those values, then you take the value which is what? Positive. So you get the value of h, which is positive. And then now after getting the value of h is where now you can come and substitute there to get the what? The base. Okay? All right, so because of time, I think we can stop there. So we will come and finish on, maybe you can do 2 or 3 problems in section 9.5 when we meet on Monday. So I will send the homework today, and I think it will be due after 24 hours. Okay. So I will write a mail before I send the problem. Avalos, Benjamin, Gregory, Ashley, Victoria, Rachel, Bailey.
I'm online today.
Rachel, you online? Okay.
Yep.
Laura, Adam, Kaveh, Andrew, Andrew, are you online? Destiny? Destiny? Abby? Aliyah? Aldo? Jillian? Remington? Rayleigh? Eric? Eric? Kayla? Rock? Thompson? Samuel? Oh. All right. See you. Make sure you do your homeworks. Make sure you finish your homework. Have a nice weekend.
Thank you.
Good weekend.
You too.